Hi everyone, welcome to my channel. We were discussing important question and answers on bipolar junction transistor. So we have completed few questions. Let us continue with the next question. Hi everyone, welcome to my channel. So we were discussing important questions on BJT. Transistors. So the previous videos were discussed by accident. So continue with that. This video discussing what do you mean by DC load line, how we are analyzing the DC load transistor in the common emitter configuration, and how we are going to select the qubits which is feasible. So what do you mean by DC load? So you find me a question like this. Outline the DC load line analysis of transistor. Any of the configuration. Most probably they'll ask common emitter configuration as it is a first used configuration of transistor. So DC load line is nothing but the straight line drawn from transistor. So for common emitter circuit line is a graph of collector current versus collector emitter. So for a given value of resistance and given supply. So how we are going to draw that? So the line is the graph of collector versus voltage of supply and resistance. So this DC load line shows all the components of C and CD which can exist in a particular circuit. So if we take a circuit, phase bias circuit, so in this circuit have the base resistance and the collector resistance. Base emitter so here the load line shows the corresponding levels of IC and C which can exist in a circuit. So if we are applying base emitter, we apply the key. So the equation will be CC minus IBR minus B or VCC which is equal to B plus B. So we are applying base emitter. So by this we can write the base current equation IB which is equal to CC and write the parameters the IC which is equal to Cephine of respectable in 8 times of IC. Next, if we apply for this load, that is collector to emitter, what is the expression of CC is equal to IC RC plus C. So here for getting the DC line, we have to go through two conditions. So to get a point A, first we have to put IC is equal to 0, the equation. If we put IC is equal to 0 in the equation, what will happen? IC is 0, so CC Then the second condition is EC is equal to 0 equation. Then what we are going to get is IC is equal to CC by C. So IC to CC by C and VC is 0. So we got the point. So we have to mark point A, point B, output characteristics. Then we have to draw this line we name it as DC by taking the conditions, that is IC is 0 to get this point A, EC is 0, we are going to get this point B. So this is nothing but the DC load line with the slope minus 1 by C. Slope minus 1 by C. We got the DC load line. How we have identify the DC bias point? That is collector current, collector emitter. When there is no input signal, the DC. This DC bias point is also known as present point, DC operating point, which defines the DC conditions of the circuit. So, choosing the point on the DC load. Then, coordinates by the and that's the reference point. This is how we write the present point on DC operating. So how we are going to choose this Q? That is, we might ask the next question. Question might be, describe the selection of the Q help of common interconnection of necessary graphs. So here we will be writing with respect to three different graphs. That is, in active region, how we are going to Q point, in nearer to the saturation region, how we are going to So you can see here, first in the active region, okay. So here I have chosen this Q point inside the active region. Then for this Q point I have taken out coordinates and I have plotted the graph. So this graph output signal which is sinusoidal. This is without any distortion. It's sinusoidal graph vector. So by this I can say that this point Q which I have chosen is the best operating. This is in active region. Suppose if you take it in the near saturation region, so near saturation region, point this point as, give this point as P. So if I take the output signal, it is nothing but clipped positive half cycle. Clipped positive cycle. It is not a complete sinusoidal form, but a clipped in the positive half cycle. So I can say that this point P is not suitable operating. Similarly, if I take it here cutoff region, this R point, name it as R. Here also the output signal which I have taken out by this point R, you can see the negative half cycle speed. So this point is also not suitable. Okay. So which is suitable operating point? Only the point which is inside the active region. That point is a proper. So this is how you can write the graph and explain how we are going to select the proper Q. Then one more last question which might be the important is they can ask comparison between the collector base, collector emitter, so common base, common emitter and common collector of the configurations of transistors. So I can write it with respect to few of the characteristics. What is the difference between common base and emitter? So with respect to input resistance, in the common base it is low, common emitter also low. Compared to base, common emitter we have some sort of kilo ohms, but here in the and output resistance will be very high in terms of 1 mega ohm. Then input current here in the common base is IE, common emitter is IB, and output current is IC. Then input voltage, the base emitter voltage, and the base emitter. So output taken is collector base, collector emitter. That is CB and CE. Then current amplification factor IC by IE, here IC by I. Because the input current is IE here input is. So the gain factor or amplification factor. Right? Then current gain will be less than unity, here it might be more than voltage gain. Again, applications. This common base is basically we use it as input stage of multi-stage amplifiers, and this common emitter is for signal. So with this, I conclude with the BJT topic, important questions on BJT topic. In my next videos, I'll be discussing few of the important questions of field effect transistors. Stay tuned.